All right, class. So today we'll be learning the 7.2b lesson. It is on nets, surface area, and volume. And these two concepts, surface area and volume, are very, very important because this is one of the main things that we teach in this uh, year in this course. So just make sure you pay close attention to this lesson. Okay, we're going to start with talking about nets, which is basically the amount of area that you need for basically all the faces of the object. Okay, you can think of it as the amount of wrapping paper something, an object needs. And you could see how the nets basically they uh, form all of the faces on the outside of the object. Okay, so just by looking at the net, you should be able to tell what type of object it is. So here I could see that there are 6 faces, right? Faces again are just the two-dimensional shapes that create an object. There are 6 faces, and then not only are there 6 faces, they are identical, right? So this tells me that this is a cube because the only time that you can have 6 identical faces is when it's cube, and each face is the same amount of area. Okay, here they're actually in order for something to be considered a face, it does need to have edges. There is a lateral face here, but ultimately this is what we call a cylinder, right? And it's a lot harder to calculate. Well, we'll talk about the surface area of a cylinder when it comes. Here, you might be thinking, "Oh, what is this? It looks interesting," right? Just remember that there are 5 faces here, and this creates what we call a triangular prism, right? So when we have the nets, this is the net, and the net allows us to calculate each individual surface area uh, easily when it's all laid out like that. Okay. Now here you could see how this is a square on the bottom, and then there are 4 identical faces around the square. And hopefully you can see that if I were to wrap these up vertically, this would create what we call a square pyramid. Okay. So we're getting comfortable with the idea of classifying the nets. Here I see 6 total faces. So again, 6 faces tells me that it's either a cube or a rectangular prism. And the fact that none of these faces, or maybe not all of them, are identical means that this is what we call a rectangular prism. Okay, I'm gonna fast forward to all the way to where we need to be, which is the surface area. So let's first talk about surface area. Surface area is the sum of all the areas of all the faces and is measured in square units. It's measured in square units because it's area. Volume, however, is the amount of space within the three-dimensional object. So volume is space, and it's measured in cubic units. Okay, area is two-dimensional, volume is three-dimensional. The net to the right forms a cube. So this is the net for a cube. Again, we know that it's a cube because all 5 of the faces are identical. And if all 5 of the faces are identical, or all 6 of the faces are identical, this tells me that this has to be a cube. Each square face has a length of 4.2. So every single kind of dimension here is 4.2. What is the surface area of the cube? Well, Doesn't that mean I just have to find the area of one of these faces that I will bold? And since all 6 of the faces are identical, doesn't that mean I can simply just take one area, 4.2 times 4.2, and figure out what that area is? So that's 4.2 times 4.2, which is 17.64. And remember, it's units squared. And all I have to do, class, and this is why finding the surface area for a cube is easy, is you just multiply 6 times 17.64, because there are 6 identical faces, which gives me a grand total of 105.84 units squared. Okay, so I just found the surface area, the entire area of this net. And remember, if I were to box this in and flip this upwards, it would create a cube. The surface area is just the area outside of the object. What is the volume of the cube? Well, again, we know that a cube looks like this, right? Obviously, there are dimensions that we can't see. But if you take 4.2 and you take 4.2, you get the area of this part. And then you just have to multiply by the depth, which is the third dimension, which is another cube, or another 4.2. So really, the volume here is 4.2 times 4.2 times 4.2. And that is exactly why, class, we call this 4.2 cubed. The 3 at the exponent is what we call cubed, because that means you multiply the same thing 3 times. So the volume is going to be 4.2 times 4.2 times 4.2, which I'm getting 74.088. And I will go ahead and round that to 74.9 units cubed. Okay, so we are practicing calculating the surface area and volume of a cube. Hopefully that wasn't too bad. And now we are going to dive into something a little bit more complicated, and it's something that we talked about during office hours last week. We're going to calculate the surface area of a rectangular prism right now. And in order to do that, let's start with drawing the net. Okay, so a rectangular prism looks like this via the net. It looks like this. Now, this is not drawn to scale, so I might have some incorrect drawings, but you can see how I have 2 rectangles that are somewhat identical, right? They're identical in size. These other 2 rectangles are also identical in size. And then I also have like a square here and a square there, right? That's to kind of close up the rectangular prism. This is, you can think of a surface area as kind of like, let's say you ordered something from Amazon and it came in a box, right? And if you took the cardboard that it came in and you cut all of the edges to the point where the cardboard would lay flat on the table or flat on the ground, that's basically what a net is, right? Okay. So the whole point of us drawing the net is that it's supposed to help us with the calculation of the entire surface area, of the entire cardboard that you needed to use to calculate for each package. Okay. Now, to me, it's actually kind of hard to visualize the edges, but let's just try our best. 20 is right here, 5 is right there. So I know that this is 20 and this is the 5. Okay. And here, this would be the 8 there would be an 8 right here, which this would still be 20. There would be another 5, or maybe the 5 is here and this is the 8. Either way, class, I don't really expect you to draw nets perfectly because sometimes it's hard to visualize. So I ultimately don't prefer drawing the net to visualize the dimensions. And now I'm going to let you in on a little secret. Okay, so please watch carefully. We know that there are 6 total faces for this rectangular prism. Okay, so the first 3 faces that I'm going to discuss are pretty much the faces that we can see. So here in the front, I'm going to call this the front face. This face right here, I'm going to call the top face. And this face on the side, I'm going to label the right face. Okay? So I'm only going to talk about the 3 faces that we could see because I don't want to confuse myself by over calculating and assuming that things are there. Okay, so step by step, what is the area of this front face? Well, I know this dimension is 20, and I also know that this 8 will transfer right there. So it's kind of like this is a 20 by 8 face, which gives me 160. Okay, we're just finding the area of this rectangle, which I think is pretty easy because you just have to multiply 2 numbers together. Now, the top is also going to be 20 in terms of its width, but this distance is not 8, right? This distance is actually 5. So I'm going to write 20 times 5, and that's going to give me 100. Does anyone have a guess as to what the third combination, the right side, will be? Now, here's another clue. We had 20 times 8. We had 20 times 5. What's the only combination left that we could still use that makes logical sense to utilize? As you can see on the right side, class, the right face is 8 times 5. And that also makes sense because it's the third combination, class, that was not used in our example. So this ends up being 40. Now, one thing I can do now is like, wait a minute, I only calculated 3 faces. Mr. Kuo, you said there are 6 faces. How are you calculating the entire surface area if you only account for 3 faces? Well, what I can do is I realize that if you have a front, you must have a back. If you have a top, you must have a bottom. And if you have a right, you must have a left. So what I like to do, which is the shortcut to this, now this only applies to rectangular prisms, right? You can't do this to other 3-dimensional shapes. This is the shortcut for 3-dimensional rectangular prisms, is I add these 3 up, which is 160 plus 100 plus 40, which is essentially just 300. And then I double it, right? The reason why I double it is because you realize there are 2 of the same exact faces of here, here, and here, and your final answer is 600 inches squared. Now again, this is only possible if it's a rectangular prism. Okay. Now in my last few seconds, I'm going to talk about calculating the volume. The volume is just multiplying all 3 of the dimensions given. It's 20 times 8 times 5, which ends up being, because you multiply the area times the depth, right? The area of the front is 20 times 8, and then you multiply by 5, which is the depth. And that gives you a grand total of 160 times 5 is 800 inches cubed. Okay, volume is actually much faster than surface area.